everybody. Witaj Kraków. So, first of all, my name is Anton Rutkievich and I work at Juna. I'm really happy to be here, to be back to droidcon, to be back to Kraków. It was a great conference last year and I really know that it will be even a better conference this year. So let's give a credit to the organizers who made all of this happen. Okay, so today we'll talk about writing a truly testable code. Why truly testable? You know, there are many ways of covering your code base with tests, but in many of them, it really hurts. You really have to rewrite lots of your logic, lots of your business logic before you can write a single test, right? So we will talk about the way where our code base is ready to be tested, so you don't have to rewrite it. So you know how to write your code to make it testable from the very beginning. Now I think I will need a little cooperation on your part. So, if you use an Android, could you please raise your hand and keep it up for a moment? Well, it's a droidcon, indeed. Okay, and now the same for iOS. I'm not an iOS developer, I'm just helping you, if there are some. Okay, maybe there are some backend developers here? Backend, guys? There should be some, yeah. Okay, maybe front-end? Okay, so it's really targeted, but anyway. And now something a little more complex. If you're using any kind of clean architecture in your code, could you please raise your hand? MVP, MVVM, you know, whatever. Oh, gosh, that's great. That's great, guys. And now the same for Kotlin. Wow. And RxJava? Well, it's completely different from what I saw the last year. It's really cool thing to think. And now, another question. Can I please ask you to raise your hand if you can say that you write tests for your production code base? A bit less, okay. And now, those who do, why are you doing it? Why do you write tests for your code? Isn't it just a waste of time? To sleep well, that's a good reason. To write blog posts, yeah. To brag about it, it's another thing. Okay. Sorry? Be confident. Okay.
Customer pays for this.
Wow, you're lucky. You're really lucky. If your customer pays for your tests, that's a good thing. Okay, ultimately, I would say that we write tests for our code base if we want it to live a long life and evolve, right? Because our software has to be modified over time. We have to develop new features. We have to fix some bugs, right? And as the software grows, as our code base grows, first, it gets more complex. So the chances, the odds of making a mistake are up, right? On the other hand, the software gets released sometimes as well. Did it happen to somebody? Okay. So the cost of a mistake, the penalty for a mistake goes up. So what you get is the fear of modification, fear of introducing modification. But you still have to develop features, you still have to fix bugs, and you even have to refactor. You know, it's a scary thing. If you take a look at it from a point of view of an average manager who doesn't dig deep into the details, it's scary because after a week of refactoring, your code base will work just as it did the week before. Think of it. If you haven't broken anything. Yeah, if you haven't broken anything. Well, you spent a week on something and there is no effect, right? But developers do this for some reason, yeah? And they understand why they do it. Managers not often do. So, from my point of view, there are at least two challenges a developer faces developing a really complex system. First one is managing the system complexity itself. And there is a great talk by Rich Hickey called Simple Made Easy, which I highly recommend for everyone. Has somebody seen this talk? No, guys, I really highly recommend it to check it out, because you know it's easier to talk on why are you taking some decisions. What's the difference between simple and easy? The bottom line for this talk, for this particular talk, is that there is no reason of making systems more complex than business requirements require, right? So your system should be as simple as possible. Okay. And the second challenge is testing the system itself. And that's what we'll talk about today. So what we'll talk about? First, what is actually a truly testable? I mean, what's the overall idea? What's the bird's eye view? Then we'll take a look at how this applies in practice, and what can you do, how can you start if your codebase is not ready yet to be tested. Okay, let's start with the definition of truly testable. Before moving to the testability of a generic module, let's take a look at something simpler, a function. Some generic function with n input arguments and n return values. There are lots of different types of functions in programming. There are some like this one, which has some inputs, passed through the arguments. It has some outputs, returns through the return value, but it also has some inputs that come in form of a global variable, and it has some outputs in the form of modification of the global variable. This is also inputs and outputs, though implicit. So if you take a look at this schematically, this is how it looks. Explicit inputs and outputs, implicit inputs and outputs. On the other hand, you have a pure function, which only has explicit inputs and outputs. So you can say that, how you get a pure function from a non-pure one. Well, that's obvious. You just remove the implicits, inputs and outputs, okay? So you can say that a function is pure if all of its inputs are explicit. I mean, all the inputs are passed through arguments, through the parameters list, and all the outputs are returned through the return value. Okay, and what's so good about it? It can be easily tested because you are in control of all the inputs and all the outputs, so you can substitute the inputs and check the outputs in the tests. You're in control. And now, let's take a look at the module. Let's try to think of a module as of a function. But not a function as we used to see it, but a function whose invocation takes some time. So part of the invocation with part of the arguments happens now, part is done a bit later, part is done a bit later again, then it can be some kind of timeout. Then you have another part of the invocation, okay? And the same stands for the outputs. They are spread in time. So let's take a closer look at how it works. And by the way, while it is a function, the same things we just done for the function applies for the module function. So if you are in control of all the inputs and all the outputs, you can test it easily. So let's now define the inputs and the outputs of such a function. What can be the inputs? Okay, so the inputs are, first, the interactions with the module API or its dependencies API. Then it's the values passed through those interactions. You can think of the interactions as of a method calls, okay? Then it's the order in which the interactions occur and the timings between those interactions, okay? Let's make it a bit more clear, but by taking a look at the code example. So, the very fact of invoking the constructor is an input. The fact that you pass some value into it is an input. The very fact of invoking a method is an input. The very fact of getting some value from an explicit dependency is an input. And the same stands for the implicit dependency. By the way, while there is no strict definition of explicit and implicit dependency, I will name a dependency explicit if it was passed to the module through its API before being used inside, and implicit if it's not. That's clear, right? Okay. So let's now take a look at the outputs. It's pretty much the same, or quite close to it. So it's the interactions, it's the values passed through those interactions, it's the order of the interactions, timings of the interactions, and also it's the modification of the module state, which can somehow be observed later. So, if we take a look at the code, we see that this is a modification of a module state, it's the output. Passing some value to an explicit dependency is the output. The same stands for the implicit dependency. So, if we define a function like this, then the process of testing a function becomes, the process of testing a module becomes just an invocation of this function. So just distributed over time. So what you do in your tests in the given and when blocks corresponds to the process of the function invocation. And what comes to the then block is the verification of the outputs. Okay. So, having that said, a module, which is a function, is easy to test if all of its inputs and outputs are passed to it either through its API or through the API of its explicit dependencies. Or, taking a look schematically, just like that. Explicit inputs and outputs through the API of the module, explicit inputs and outputs through an explicit dependency, and implicit inputs and outputs through an implicit dependency. So what do we do to make a module testable? Well, exactly, we remove the implicit dependencies, make them explicit. Okay, I will leave it with you for a moment, and we'll continue with the practice right now. So, how it looks in practice. First, it's really hard for me to imagine a code that can easily be tested if the code base itself doesn't follow any clean architecture. So I will take MVP as an example, but generally anyone will do. What do we have here? We have the UI platform framework, which is isolated with a view layer. On the other hand, we have the platform APIs and third-party APIs, isolated ideally by the platform wrappers. We'll talk on that later. And we will have a presenter layer, and we have the model layer. By model, I mean something that encapsulates all of your business logic. It can be, you know, the repositories, the services. You can even call them microservices and troll your backend team who are still on the monolith architecture. That's a good thing to do, by the way. So what is being tested? Exactly those two parts, the models and presenters. So what we'll take a look at. First, we'll understand what is explicit. What do we aim at? Then we will take a look at how the most common implicits look like. What are the most shady of them? Then we'll talk on how and why we should abstract away the platform, and also cover the mocking of the dependencies in tests a little bit. So let's start with the explicits. Just to repeat how they look and what do we want to introduce in our code base. So this is a module, this is an input. We can also pass an input in form of lambda, which returns a value. It's just kind of delayed input. We can also pass an input in form of the observable, Rx observable, obviously. We can call a method, it's an input. The parameter to the method is an input. And everything all the things above done through an explicit dependency are also explicit inputs. So this is the explicit inputs. It's not the complete list, but it should give you the idea to understand whether the given input is explicit or not. Now regarding the outputs, it's returning some value from a method. It's returning some value through a lambda. It's returning some value from an observable. And, passing some value to an explicit dependency. So this is the explicit outputs. It means that we can observe the results of them, right? Okay, now let's talk about the implicit part, which I am totally sure resides in your code base. So first one is the statics and singletons. Well, the Uncle Bob Martin had been telling us for nearly 20 years, let's say, that singletons are bad, right? Why? Because it's shared state, it's hard to be tested, and, well, that's actually true, right? So what do we do with singletons? As a high-level idea, we extract them as an explicit dependency. Okay. Next, as an example of, we take the random generator. Here we don't call any, static method. We don't call any singleton, but still we have an implicit input because the constructor itself of the random takes, invokes those implicit inputs like time or whatever. So we have no control over what comes out of this invocation in tests. We cannot replace this in tests. So what we'll have to do is to pass it as a dependency as well. Some kind of service which provides you random values, which you can later mock in the tests. Next thing is time. It might not be obvious at the first glance that time is an implicit dependency, right? But it soon gets. And, the easiest example I can imagine is when you have some module and you have some timer in it. If you write a test that covers that module, then you don't really want your test to run for 2 or 3 seconds while your timer executes, right? You want to be able to control time inside of your tests in a more precise way, right? So this way, you get away from this problem. You also provide time as a dependency. And this way you can control it in tests. And there are also other benefits that this brings. Because if you have a single place in your system where you control how your time behaves, you can introduce some system-wide modifications to it. For example, at Juno, we were able to introduce time correction based on the GPS coordinates, coordinates timestamps, just because we did that. We had a single place to talk to the time in our system. And now comes something more interesting, especially for the guys who just arrived, for the RX guys. So what we have here? We have an observable, and there are some operators that use the default schedulers. You know that RX schedulers are not only main thread schedulers, but they are also most commonly IO schedulers or time schedulers. And by default, RX provides you with some implementation, which is static, which is global. It can be replaced in tests with RX hooks. And let me tell you our story on how we got our fingers burned with this approach and how we got away from it. So I have a colleague of mine, Artem Zinatulin, who obviously also works at Juno, and he told me several times that, well, passing, using the default schedulers here is a bad idea, and replacing them as RX schedulers hooks in tests. Why? Because it's a global state. It's a global state which you control in one place. Well, just global state. Well, I agreed with him, but it works. It works. You can do it, right? It seems to work, and nothing seems to be broken until it is. So somewhere between the first, between 1,000 and 2,000 tests in our app, we've added just another tiny test that didn't have anything related to the Rx schedulers. And then we found that our tests started to fail randomly. Not the tests that we added, but 50 other tests. And they were failing or working randomly. No idea why. So we took a closer look. It turned out that all of them used some sort of Rx schedulers, and the schedulers themselves were replaced with the Rx schedulers hook, right? So we took a closer look at when do they fail and when do they pass. And it turned out that on one CI machine, they constantly fail. On the other CI machine, they constantly pass. Well, that's something. We took a look at the environment. OS version, the same. JDK version, the same. Android SDK, the same. Artyom Zinatulin was playing with decorizing the process of the build at that time, so we decided to give it a try. So we've embedded our build process into a Docker container, so the environment became synchronized, and we've run this build inside of the Docker container on those two CI machines. And you know what? On the one machine it failed, still. On the other machine it passed. No idea why. And you know, the release is close. Release is kind of always close if you release every 2 weeks. Well. So then we took a closer look at the machines, and it turned out that one of them was faster and the other one was slower. And tests were always passing on the slow machine and always failing on the fast machine. And the release was close. So I made a strong-willed decision and reconfigured the CI to make the tests run only on the slow machine. Well, and everything went fine for some time, you know. We were approaching the release, it was getting even closer. Now it's just now, and we built the release build, and guess what? It failed. Because our release build is built on third CI machine. Okay. So I made another strong-willed decision, and, well, this release didn't have tests run on it. We obviously checked that everything works on local machines, that the tests themselves are passing, but I have had some, you know, bad feelings about it. And after the release was launched, I was obviously made a third strong-willed decision and rewritten all the invocation of, you know, those operators that use the implicit schedulers to be explicit ones, just like that. And, well, needless to say, we didn't have any issues since then. And I think the most shady one are the formatting and locales. Because all of the methods, almost all of the methods with locales and formatting have an option of using the default locale. And even worse, take a look at this example. So we specify a simple date format, which just formats the timestamp. We've specified the format explicitly, so no locale dependent things here. And we want to write a test for it. So we create some timestamp. We make our expect to be an empty string because we're lazy. Then we execute the code, assert that actual is equal to expected, and it obviously is not. And we find out that the actual value looks like this, the formatted output. We run the test, and it indeed works, right? In our time zone. But our CI is in a different time zone, right? Because it's on Amazon or something like that. So we get anti-Volkswagen tests, which always work locally and always fail on the CI because of those 2 digits. So the bottom line here is whenever you have something related to formatting locales, currency, time zones, make sure that you pass those dependencies explicitly so that you can mock them in tests. Okay, now let's talk a bit on why and how you should abstract away the platform. Let me say that it's not a mandatory thing, but it makes your code base cleaner. So, one place where there is a border between platform and business logic is the view. But it was discussed in the MVP in detail, so we will not stop here. We'll rather talk about platform wrappers. So, imagine that we have a platform API or third-party API. In the very general case, we have no control over those APIs. And it's not really easy to mock them in the general case. So, imagine that such API is passed even as explicit dependency to your model layer. So what do we get? Part of the model input cannot be mocked, cannot be controlled. So part of the model behavior becomes untestable. So that's why it might be a good idea to isolate the platform API by introducing platform wrappers. It's kind of wrappers that take the platform API and expose some interface that you create and you can mock it. Another good thing about them is that they can help you fixing a poor API design, right? And you don't always need all the dozens of APIs the platform has. You sometimes need or, well, use just 3 of them and not a bunch. So, another thing, again, not mandatory, is, implementation specific, but still. If you have a Dagger module in your Android application, which depends on context or some other platform API, it is totally fine for this module to provide some platform wrappers that uses the context. But again, in my opinion, it's not a good idea to provide the context itself. Because with this approach, all of your models in your dependency graph can say that, hey, I need the context. Hey, I need this platform API. And they start dependent on the platform explicitly. Also, it might be a good idea to keep all the platform wrappers in a single or several separate platform modules, so that you know that the border between platform and business logic lies in those 2 or 3 modules and nowhere else. Again, it's not mandatory, but it's a good practice in my from my point of view. And well, I just want to remind you that platform entry points should ideally be as simple as possible. Those are activity, service, and all the others you know. There is an approach where activity can implement view, but in my opinion, it makes it a little bit, complected. It first becomes a view, and then it becomes the place where your dependency injection gets assembled. So it's kind of 2 things combined together. Okay, now regarding the mocking. There is one approach that works everywhere. Programming through interfaces. It's again 20 years old. So if you have an interface and an implementation, you can either create a testable implementation in your tests, or you can mock the interface with your favorite mocking tool or interface, tool or framework. This approach faces some critics saying that, if the interface has just one implementation, it's not worth introducing. But from my point of view, it first makes the testing easier, and second, those header interface makes the public API of the module visible. You can easily see what is the public API, how big it is. Maybe it's too big for a single module. And another thing regarding Kotlin is that in Kotlin, you might know that all the classes are final. So if you don't like the interface approach, you have to do all your classes and methods open, which is not a good practice as for me, but still it works. I must admit it works. Another alternative is mocking finals with Makita 2 or PowerMock. The last one, I really hate it because it allows you to do so many nasty things that it's better just not to introduce it at all. So, okay. So, how do we start if our code base is not yet ready to be tested? Imagine you've written it even for several months and you haven't given a thought about how it will be tested. I would suggest starting with the model layer. So you have kind of things that don't depend on anything, right? So we first build our dependency graph, global dependency graph. We start with the leaves. These are either platform wrappers that only depend on platform APIs or the models that don't depend on other models. Then, once we have them, we can build a higher level, and again, and again, and again, and this way we have the dependency graph built. Easy, right? Just like that. Well, obviously, it's much more complex than that. You will have to understand the process of the initialization of your app. You will have to understand what components depend on which ones, in what order. But in the end, it might be worth it. You know, sometimes it's not that easy to extract singletons in one shot because they might be a God object or whatever. So if you have a singleton, this is a singleton in Kotlin, and this is a usage of such singleton, you can do the following trick. You can create an interface which mirrors the public API of the singleton. You can make this singleton implement the interface, and then you pass it inside as an explicit dependency, passing the get instance from the outside, right? This will help you to have some intermediate step, not refactoring everything in one place. Okay, as a result, you get all of your implicit dependencies become explicit through some sort of dependency injection, and what you have after finishing this, you get control. You can replace all of them in tests. Then, you gain control over the initialization process, which is really great, I must tell you. And by the way, you can cover your models with tests, right? You have your models in your dependency graph. All of them are passed through dependency injection, etc., through interfaces, and you can cover them with tests because they are all explicit. And then, once you have the dependency graph, you can take an activity, which is an entry point, encapsulate it with view, take your dependency graph you've just built, and create a presenter, and obviously cover it with tests. Okay, so that's the story. That's a high-level story, obviously. If you've done all the things we've talked about in a good way, then you have another bonus. So, if you take view and platform wrappers layers and make them, you know, not blurred, so you know where your view layer is and you know where your platform wrappers are. In this case, you can replace them with test implementations and test everything that comes inside with the complex integration tests. But that's a different story. And, you know, for now, I just want you to start kind of covering your code base with tests and make your tests be green for a reason, not just because you have them. So that's it from my side. Thanks for your attention, and yeah, thanks.